Dear students, Wenqi just remind me that we didn't provide you any video for our course on this Monday. So where we did the review session about our courses in the past 4 weeks, I guess. And I said that would be a possibility for me to give you a video on the overview that I prepared for you. But we still managed to make maybe that was a very quick overlook for those slides I made. That was rather like 5 minutes or so. I prepared actually around 15 minutes or 20. It wasn't meant to be very comprehensive and sophisticated overview for you to take. It is rather an appetizer actually for you to really think it over and solidify your knowledge, connect them for our previous few weeks. But anyway, maybe a little bit extended version than those 5 minutes would be a good idea, and maybe it is also a good idea for those who didn't manage to attend the Monday session, and you could just give yourself a fresh memory. It is probably not so necessary for you to think anyway for this week, because we didn't have a specific really assignment on this session. I think it will be anyway a good idea for you to think and to look at about this review while you prepare your exam next week. All right, let's begin with some slides that I showed you on our day 1 lecture. At that time, you probably don't really remember or don't really realize what all these things are supposed to mean. You know a general overview, you know a overall picture, what I just showed to you. But I think if now we look at back all these slides and all this content with the knowledge that you have obtained in the past few weeks, I think then you would have a very good, fresh, and fulfilled kind of overview, much more vivid than your day 1 lecture. So now I try to go through with this very basic slides again for you. Hopefully you can just try to go through the detailed slides afterwards, and also our reading book, textbook, where you can get much more detailed information. So we said, what is material science and engineering? I think at the very beginning of the course we said materials and engineering. Material science and engineering is an area that is from the overlapping of physics and chemistry. And we gave a very short limited list over there. You probably didn't realize how much that meant, but I think now with our courses from this few weeks, that made probably a very good impression for you. If you just look at those few keywords that are listed here, you can see solids, atomic bonding, electron behavior. These are all the things we have been talking about, right? Microscope, thermodynamics. We didn't talk in detail, but we scratched a little on the surface. So we didn't talk about too much on quantum, so that is very slight knowledge when we were talking about atomic structure. So kinetics is always there. So we have diffusion, which is a kinetic mechanism. And when we talk about creep, it is also related to kinetic. So everything is correlated to each other in all these different courses. And of course, we didn't cover many physics or chemistry concepts, but somehow our topic is really built on those fundamental knowledge that you got from your high school or very basic university study about physics, chemistry, and even mathematics. Yeah, so it was not really listed here because those mathematics is already a subcategory of certain physics. But I think you also realized we need your knowledge from calculus. We didn't talk too much about tensor matrix. Of course we could, but since you have solid mechanics and continuum mechanics lectures, that is excluded from this session for you. I think this gave you really a good kind of knowledge scope of material science and engineering. Then we moved on with our very basic important concept about material science engineering, which is about this famous tetrahedron: process, structure, property, performance. So if you forget anything from this course, please remember this. This is really the key element or the key chain of material science and engineering. And then we gave you a definition or kind of a characterization about material science and material engineering. They're in general the same, but as you know, what is science, what is engineering, we have already talked about that really very, very at the beginning on our introduction course. So I think you know what science and engineering, these two terms differ. That is also a reflection you could find when we just talk about this tetrahedron. So for material science, we're more focusing on the relation between structure and property, and also all the fundamental knowledge, theory, models, characterization method about structure and property. That's why you probably also realize we spend really quite some energy on these two terms. And for structure, it involves many fundamental knowledge like physics, even chemistry as well. And for property, there's quite some mechanics, physics as well. So even mathematics, yeah, so they're all there. And of course, after you master those two correlation terms, what you can do is to do a design or discovery of new materials with new properties. Yeah, that's the kind of two important elements about material science. And in the past week, week number 4, I guess, you finally moved to the part which is more focusing on engineering. So that is the correlation between performance and process, and the process back to structure. Excuse me. So the process to structure is actually rather fundamental as well. Yeah, we didn't go that fundamental, but you could. So in general, these two connections or these two elements are a little bit less fundamental and they are more engineering orientated. The goal for you learning these two parts is especially to serve our engineering purpose, which is to create new stuff, right? To create products with the existing materials or develop new material processing technologies. Yeah. So these are the two fundamental aims or goals for material engineering. I think from our last piece of elements that we got from this Tuesday, you finally get this full picture about this tetrahedron. If you just look at this outer layer, this is more like a kind of application examples or a little bit substantial reflection of this tetrahedron you could really do in the reality. So when you design material, you think about the alloy, and when you just do your material engineering, you think about select. Yeah, you select from the existing materials. All right. And this is a very important picture, or very tough picture for you to understand when you were just on our first, or let's say one of the first, I don't Remember, this was given on Monday or Tuesday for our first week. I think it's on Monday. And you don't really realize what we're talking about here. Yeah, so we're showing you one diagram. The x-axis is so-called cooling rate. You probably didn't know at that time what cooling rate really is referring to. I think now you know it's very, very well. And the y-axis is about hardness. So maybe you remember this is Brinell hardness. And this is so-called property. So this is a correlation between, let's say, process and property. Yeah, it's not the direct connection that I showed you, but this is a rather indirect, because process will decide so-called structure. Yeah, the structure finally decides your property. Yeah, but for engineering purposes, sometimes you could just overlook the structure. You don't need to know what structure it is, because for engineering purposes, we just need to focus on property and the processes. Then you can design your product. You can design your processes with that. But let's just look at a little bit detailed of this figure. So it tells, so of course, this is referring to a steel alloy in our context, but actually you can also go to other alloys to draw such a figure. And this is a very application-oriented example. So when you just work in the future, for example, in a steel company, in an aluminum company, zinc or magnesium company, when you just try to design your material or produce your material, you always need to look at such a diagram on a similar one. Yeah, because your supervisor, your customer will come to you and say, look, we want to have a very strong aluminum magnesium alloy, and we're aiming the hardness of certain number of hardness. Yeah, try to produce for us. We don't care what exactly microstructure it is, and we just aim at the product. Yeah. So you, as a material engineer working in this company, you should know what microstructure you are aiming at and what kind of cooling rate. Of course, it's not gonna only about cooling rate, but cooling rate is the key factor for your processes. Yeah. Then you can finally deliver your task and deliver the product to your customer. So this is exactly what you probably will be doing if you're in such a business, right? If we're talking about steel, let's say you have such a diagram already. With your knowledge that you got in the past weeks, you exactly could understand what they are. For example, if we just look at the very slow cooling rate, so very, very slow. So what we get here, and probably you remember, we have the process with the slowest cooling rate, or almost not cooling. Yeah, that is the spheroidizing. What you produce after that is the spheroidite. Yeah. So you have the ferrite, and you have this very small, or rather small particle cementite. Yeah, it is very soft. Yeah, and that's why you have rather small hardness value. Yeah, and when you just do not use that slow cooling rate, you go a little bit faster. So something like full annealing, so that is already faster. So you are just cooling with the furnace, right, together. And it is already much faster than the spheroidizing. And then you will get this nice large grain pearlite structure, yeah, plus your ferrite. So that gives you a rather, compared to spheroidite, it is harder, but relatively still soft face. Yeah. And if you just further increase your cooling rate, what you get? Yeah, you get martensite, right? So this is the very fast cooling rate you can see here. But you could have two types of martensite. Yeah, if you're aiming super hard, yeah, super high strength martensite, you can choose to have we call it a fresh martensite, or in your textbook it's just called martensite, which is this needle-like martensite and very tiny microstructure, very distorted crystal structure with the BCT structure. And of course, I mean, from the same cooling rate, but if you just try to do a little bit post-processing, a heat treatment with quenching and tempering. So quenching is already there, yeah, because martensite itself is quenched. What you need to do is just a tempering. You will get so-called tempered martensite. Yeah, this is exactly how it looks like. You have ferrite plus very small, tiny cementite. Yeah, so if you just compare these two, so I think I asked you during the course, what is the difference between the tempered martensite and sapphirite? And they're both ferrite with base and a certain cementite in a rather particle form less than a laminar form in a pearlite. They look similar, but why they differ so much? Yeah, they differ due to the size of the particle. If you just look at the scale here, so the particle you look at in your tempered martensite, although they're both cementite, are much smaller. Yeah, so that is the key element to increase your strength, increase your hardness. Yeah, I think this is a very nice figure for you to just reflect many things we have learned in the past few weeks. It is giving you much more rich information than we just talked about during the day one, right, lecture. So try to correlate all this by looking at the slides back again. And then I want to show you different materials that we have investigated. We showed this to you at the very beginning. We will talk about metals, ceramics, and polymers. And I think we touched all of them when we talk about structure. Especially, we try to correlate certain atomic structure, atomic bonding with certain types of materials. And we also correlate a little bit about crystal structures with all these different material groups. And when we just go to properties, they are still kind of showing you certain information, but with a less resolution already. When we talk about processes, we didn't really touch too much about ceramics and polymer, then we focused on metal. Actually, for those two, structure and the property part, we also focused mainly with the metals, because we want to give you a chance to look at the full picture, the full connections of those four elements in the tetrahedral with one type of material, which is metal, and you can really get everything correlated for that tetrahedral with this one material. And next week we will actually give you very brief and quick overview about ceramics and polymers, and you will see how their structure looks like in detail and how their properties will be in generally looking like, and what are the processing methods we're using for those two materials. So the level of detail will be very less compared to what we traded with metals, because it is not possible for us to trade with the same level of details within this short period. But it's good for you to know how they will be, and of course you can also discover further when you just read the textbook. Yeah, and then we also focused on different property types, and I gave you, we will have 6 major properties, and so far we have been mainly focusing on mechanical, and that is also the idea, the same idea is applied here. So we want to just make sure everything is going to connect it in the tetrahedral with one property, one core property, and the rest of them will be a little bit similar. And as mechanical is the main important property that your major should care about. That's why mechanical property is the key point that we focused on. I think, for example, some of you are from electrical engineering, School of Electrical Engineering, and you are probably interested in some electrical properties, and of course also the rest. This will be also briefly covered next week, and you will see how those 4 kind of connections will be about, and when we just talk about different properties. But that will be very brief, as I said. Of course, these are the 6 key mechanical and the 6 key material properties. And if you just look at this wheel here, you could have actually a lot. Yeah. So we also touched a little bit, for example, density. We talked about quite a few words over there when we talk about the crystal structures, but in general we touched only basic elements of this rather comprehensive wheel. So of course you could find more information about them in the textbook, and you will also learn them much more when you go to your master level. And finally, I want to show you this lecture flow again. So if you just missed, I think that was shown for our Monday lecture and was again on our Tuesday lecture. But I noticed not so many of you attended both sessions. That's why I tried to include here and gave you a overall flow again. Our lecture, the whole 12 sessions, let's say, are actually very nicely connected via this tetrahedral. I will show you how. You can also work on a little bit details after I show you how. So we have these 4 elements, you know them, and the key for us to learn is one by one. First, the connections, but how they're connected are not by these words, right? The connection is defined by these 3 main terms. One is characterization, one is theory. So characterization, we're mainly talking about the experiments, methods, and data, so measurements. And theory is all these definitions, equations, and kind of qualitative correlation. Yeah? And modeling is something you mainly experiencing, let's say, during our exercise sessions, at least for the first half of the whole lecture. So you see all of these 3 are included in our lecture. And then this is also the core you are trying to get each session. And then we try to get the connections. So for the structure part, probably you remember we started with atomic structure. You try to recall all the knowledge there about electron and atomic bondings. And what are these bondings existing, or how they are different when we just talk about different materials. So these are the key information for you. And then we moved on from, let's say, 2 atoms, because when we talk about atomic bonding, it is relatively focused on 2 or let's say multiple atoms. But our material is not just by few atoms, right? It's thousands, millions of atoms. So we zoomed out a little bit from atoms, and now we're looking at lot of atoms together, then we need to talk about the crystal structure. So how the atoms are stacked together to form our materials. Yeah. But during that lecture, I think you realized the difference between the crystal structures and what they will influence certain mechanical properties. For example, even the density. And then I think the most important part for you to realize is this crystals are the so-called grains in your microstructure, in your material. They are not just one, they could be multiple, right? And when you even have the same overall, let's say, material, but their crystals could be also different. That's why you finally have another definition, which is called phases. Yeah, for example, if you think about the certain steel grade, you see it as a steel, and they are all BCC. Yeah, but their crystals are different not only from crystallographic orientations, they are also different from their basic arrangement in terms of the carbon interstitial composition. Yeah, that is what we're talking about. For example, difference between pearlite and ferrite. So they could exist in one certain steel. That is the final level we're talking about structure, which is not given at the very beginning, but a little bit later when we talk about processes, right? But that came with a reason, because you need to have some basic knowledge. But now, if you try to take that back to the structure level, you actually see a very beautiful picture, right? We're just zooming out and out. Of course, if you zoom out further, you see your material as a macroscopic piece of material, and then you could characterize on the properties, right? And we've started with the elasticity and went quite deep to plasticity, and here we really try to find out the mechanisms about elasticity and plasticity. We go back to the structure level to give you the mechanism about these two observations. Of course, you learned the hardness very quickly, but as a very important engineering measure. And we kind of focused quite a lot to failure, because it is such an important measurement for our engineering materials. And this is something we would like to definitely avoid. We could be a little bit less efficient with our material choice, but we don't want to risk for any failure. And the last thing about property will be physical properties. So here they will be referring to electrical, thermal, magnetic, optical, and so on. You will visit all this rather in a poster fashion, you will see next week. And that's all about properties. And then we know if you just take properties into a group, you would formulate so-called performance. Yeah, because properties is something we try to define on a single level or single material. But when we just talk about performance, usually it is an integrated level. So we're not just talking about brittle failure, we will talk about brittle and ductile, we will talk about fatigue altogether for one material. And more importantly, it is about rather a product, not just a material. So this is just zoomed out again. Yeah. So we're not just talking about a tensile specimen. We're talking about a turbine blade, for example. Yeah. So this is the whole kind of spectrum. When we just zoom out and out, you now see it better. And finally, we stopped with just our imaginary world, as if all the things are exhibiting themselves to you directly. No, because we have to make all the stuff. That is the essential part of process, how to produce our stuff. Yeah. And over here, you could know the process is the way to just realize your performance. Yeah. So how do you want to design process is fundamentally decided by your performance indicator, and which probably came from a designer or so. For process, we introduced you 3 very basic principles, which are diffusion, phase diagram, and phase transformation. As these are the prerequisites for you to get the final point of process. And in the end, we showed you the major processes. Let's say if you want to just get a product, we showed you rather with a live demonstration, which is how to produce a kitchen knife. Of course, our resolution over there is pretty general, but I think it gives you a good idea and good overview about how things are produced. Yeah. And during that session, I think you also know process will finally decide your structure, as I just showed you in the previous slide. Good. I think that is what I want to tell you about the general lecture flow. And all this flow that I just demonstrated you is achieved focusing especially on metals. Yeah. Next Monday, we're going to demonstrate how this flow will go over, especially for ceramics. So very fast, but you will see how you apply this general flow to another material. And then you know really better what we're talking about. Good. And the rest is rather a kind of your reviewing. I'm trying to give you really an appetizer for you to prepare your exam and review what you have learned. This is a way that I like the most to study new stuff. So you try to build up a whatever, could be a mind map, could be a structure map like I'm giving you here, and any other things. But try to really connect all the dots that you have learned session by session, pieces by pieces together, and to see the overall picture. I mean, the previous slide is already a very good overall picture, but it is rather general. I would hope you could develop something as I showed you here on your own to get a little bit zoom in overall picture. So this is one figure taken from the book, which is not a very good one, I have to tell you. But I'm giving you as kind of an inspiration point. You can try to design your own. For example, the atomic structure is missing here, but the kind of method is a good thing for you to borrow at least. You start with the structure and you try to connect it with the demonstration that we showed you when we talk about materials engineering. You know all these phases. So this is a way from small to big. And of course, we cannot just talk about one abstract material. That's why here the book is giving you example from the steel perspective. Of course, you can think about something from other perspective. And that is about the structure. And here is a zoomed in figure about the properties, because you know how all these 4 elements are connected. Here is rather a zoom in about each element. So for properties, this is really a very brave overview. I think you can do quite better than this one. So here is starting from mechanical properties, and it is trying to bring elements about mechanisms, and it's also trying to touch a few examples when we just talk about our iron and the carbon phase diagram with the let's say martensite or whatever phase. You can think of a different one, of course. And you can also do the same for the processes. Yeah? How do you just connect on elements in processes over there? So this is rather, I would say, a okay overview because it touches the basics, but it overlooked the diffusion, for example. It directly started from phase equilibrium, that is the phase diagram, but it includes nicely about those diffusions here, okay, but that was rather simple. But it includes all the elements when we talk about in phase diagram, and then the phase transformation with isothermal and continuous cooling, and then it combines quite good with these processes we just introduced to you last week. No, this Tuesday. So different annealing processes and also quenching and tempering. So this nice heat treatment processes. Of course, it's not including the casting and forming processes that could nicely enter to such a diagram as well. Yeah, but that is just, as I said, a starting point for you to think about it, to organize your outcome from the course. I think you will benefit from doing such a practice of your course. All right, I think that would be the last slide I want to talk to you. I'm sorry it is a little bit long again. I hope you would enjoy it. All right, everybody, see you next week.